And with that in mind, again, this session is now being recorded. Also, what I'm going to do is I'm going to start sharing my screen with you guys. I'll be going through each of these slides one at a time, and I'll be asking you if you have any questions as we complete each slide. So try to leave your microphones off until you do have a question, and then when I ask you if you have any questions, you can turn that microphone on and ask it. Right? So try to verbally ask your questions rather than type them out in the chat, just because it's going to be hard to bring up the chat, the list of participants, and the slides all at the same time without them starting to block each other out. I'll make sure everybody can still view these slides as we're going through it. All right, so with that in mind, I'm going to start sharing my screen, so let's go ahead and do that. And hopefully everybody can see that okay. Just real briefly here, just to make sure that we are all on the same page. Raise your hand if you can see the screen. So there's a way that you can raise your virtual hand down there. Raise your hand if you can see the screen. And we'll see if anybody can't. Okay. So it looks like most people can see it. Again, try to raise that hand if you can see the screen. At the very least, you'll get some practice interacting here. If you're just coming in, try to have those microphones turned off until you're ready to ask a question. All right, looks like most people were able to see it. All right, so with that in mind, go ahead and lower that hand. Everybody go ahead and lower your hand until you are ready to ask a question, and then we'll have you raise it again. All right, so again, if everybody's on board here, go ahead and lower that hand, and we'll get started. Cool. All right. So let's go ahead and begin this review session. So this is the review session for ECON143. I hope that's what everybody is here for. With that in mind, we're going to go ahead and be talking about what you're going to need to know for the exam coming up. So first thing I would do is I'd make sure you go through your class notes first. So hopefully you've been taking notes while you have been watching these videos. If you haven't, you just want to rewatch the videos, that's another option, although that might take a little longer. I have posted a study guide up there on iLearn for you, as well as these review session slides have been posted and a pre-recorded review session video. I also try to post this up there as well sometime later today after the review session ends. Other than that, I would try to go back through those thought-provoking assignments and maybe your homework problems to make sure you know how to answer these questions or similar questions. If you go onto iLearn and you go under assignments, you'll see the folders in which these assignments are located. There's directions under those folders about how to go back and review those homework problems. And as part of you going back and looking at them, I have explanations on how to do them in there. I also have an answer key for the homework posted so you can see how to complete those types of questions. Then finally, please email me or join those Zoom office hours if you have any questions at all. I'll be having another set of office hours right before your all's exam from 8:30 a.m. to 10:30 a.m. on Wednesday. All right, so feel free to ask any last minute questions you might have before your exam coming up at 12:30. I've sent out directions on how you're going to take this exam, right? As part of those directions, remember that the exam will be open between 12:30 and between 12:20 and 12:40 p.m. on Wednesday. So you can start the exam anytime in that 20-minute window, and it doesn't matter when you start it, you will have 80 minutes as soon as you do start it, right? So if you start it at 12:20, right, then you will have until 1:40. If you start it at 12:40, you're going to have until 2 p.m. on that Wednesday to complete it. So you have 80 minutes no matter when you start it. All right, so keep that in mind. The reason why we have the staggered start times is because if everybody tries to start exactly at 12:30, it might crash the system, and we don't want that to happen. right? So are there any questions about the suggestions for studying or directions for taking the exam? If you have a question, feel free to unmute your mic and ask it. Nope, no questions there. All right. So if there are no questions, let's go ahead and get it started. Remember what we began with in chapter 1, we talked about that definition for environmental economics. That is the application of the principles of economics to the study of how environmental resources are managed. Remember that economics says that people do respond to incentives or changes in costs and benefits in a predictable way. The benefit of an action goes up, people will be more likely to do it. If the cost of an action goes up, people will be less likely to do it. We talked about some policies that took advantage of this idea. One of which is that Worcester pay-as-you-throw trash collection system, whereas instead of paying a flat rate, no matter how much trash you throw away, you have to pay per bag of trash you throw away. And when they instituted that system, we saw how the amount of trash that people in Worcester were throwing away was far below the national average, and the recycling rates drastically increased. Of course, the system wasn't perfect, right? We talked about how it may have led to some illegal dumping. Now it's kind of hard to enforce across apartment complexes where people use a communal dumpster to throw their trash away. We also talked about the California's plastic bag ban, right? We talked about how that removed the amount of disposable plastic bags that you see on the beaches and in the oceans, right? So it drastically lowered that. But it did increase the sale of garbage bags because people were using some of these bags as garbage bags. But now that you have to pay 10 cents for bags and reuse them, right, people started buying more garbage bags instead. So it might have increased, again, production of that kind of plastic bag. So again, it didn't completely reduce the amount of plastic as much as we originally thought, because it was just offset by that increase in plastic, the garbage bag use. And then we talked about reverse incentives and secondary effects and how that can cause some environmental policies to backfire. We talked about the Endangered Species Act designed to protect the red cockaded woodpecker actually may have lowered its numbers further. Remember how that worked? There's a certain tree that this woodpecker likes to nest in. If you have a woodpecker nesting in that tree on your property, you're not allowed to build within 50 feet of that tree. So when people bought their properties and saw a bunch of these trees and knew about these laws, right, but they didn't have any woodpeckers nesting in them just yet, they cut down the tree before the woodpecker has a chance to nest there, and again, destroyed the habitat of the woodpecker even further, causing their numbers to dwindle. So a policy designed to increase the population of the woodpecker actually lowered it. And we talked about that New Delhi cobra bounty, which said that in order to reduce the cobra population, we're going to give you, say, $10 per every cobra head that you turn in, right? People started killing cobra heads on their way to and from school and work in order to gain that money. Fortunately, they started to depend on that money, so they started to breed cobras in their homes. And when people didn't see the cobras in the streets anymore, they repealed the bounty, and so people let all the cobras that they were breeding in their homes back out on the streets. There's actually more cobras than there were before. So again, a policy designed to reduce cobra population actually increased it. Then we talk about the Clean Air Act, which said that there is policies in place that are affecting any new buildings that are built. They have to be built to certain specifications and be subject to certain requirements. If you're an old building that's been around before, right, you're kind of grandfathered in under this policy to where you don't have to meet those requirements. And the idea there is that we're going to try to protect the environment without necessarily hurting any old established businesses. Unfortunately, that causes businesses to hold on to those old, more pollution-causing buildings more for a longer period of time than they otherwise would have, because if they build a new building or retrofitted their old building, they'd be subject to those new, more stringent requirements. Right, so again, a policy designed to maybe protect our air or reduce the amount of pollution being emitted in the air might have increased it due to those perverse incentives and or secondary effects. So are there any questions about this slide before we move on to the next one? Does anybody have a question about any of the stuff we talked about here on this first slide in chapter 1?
Yeah, I have a question.
Yeah, go for it.
So I guess the middle bullet point, so those ones are just changes in costs and benefits, and then perversive incentives causes secondary effects. That's the difference.
So these first two examples are ways that we try to use people's incentives in such a way to protect the environment. Again, both of those did have some secondary effects associated with it. The last one are ways in which environmental policy has backfired to achieve the exact opposite of the goal that we hope to achieve.
Okay, thank you.
Yep, no problem. Any other questions about this first slide? Nope. All right, let's move on to the next one. All right, so make sure you know the difference between positive and normative economics. Remember, a positive economic statement is one that is testable. For example, we could say like it's 82 degrees outside. We can go out there and look to see if it's 82 degrees. That's something that could be true or false, but we can test it to see if it's true or false. A normative statement might be something along the lines like it's too hot outside. That's not testable because it's based on somebody's subjective value judgment or opinion, right? So whether or not it's too hot can't be tested because what's too hot for one person might not be hot enough for somebody else, right? So for example, if I were to say that the United States emits 5 trillion tons of pollution into the atmosphere every year, right? Again, we can test that to see if that's true. If I were to say something like the United States pollutes too much and we should reduce the amount of pollution that we emit, again, that is more of a normative statement. It's not really one that is testable. Make sure you understand the difference between the moral approach and the economic approach to studying environmental economics. Remember, the moral approach elevates the environment to being morally superior. So anything you do to protect the environment is inherently good. Anything you do to damage the environment is inherently evil. That is not the approach we use in this economics class. We're going to be using the economic approach, which just says it's more about competing preferences and cost versus benefits rather than one side being right or the other side being wrong. Right. The next bullet point says, know the truths and fictions regarding the climate change debate. Right. Remember that those hardcore conservatives or people on the far right would say that climate change is a hoax and it's not happening at all, or there's zero evidence that it's being contributed to by human beings. Whereas people on the far left would say not only is climate change happening, but it is there's universal scientific consensus that is being caused by human beings and could lead to the destruction of the world in as soon as maybe 12 years, as I've heard it before anyway. And remember that neither one of those is necessarily true. Climate change does appear to be happening. Again, the Earth has increased about 1.4 degrees over the last 100 years. Now, remember that the Earth's temperature does fluctuate pretty naturally. There's been times where it's been just as big of an increase in temperature without nearly as much human activity. And again, as far as there being universal scientific consensus to say that human beings are causing it, well, scientists are kind of still unsure about the extent of human activity when it comes to climate change. Right? There's some studies out there that say that human beings are definitely the cause. There's some studies out there saying that they're not. There's a bunch out there saying that there could be, but we're not sure exactly how much. So again, both sides of the political agendas there kind of scream things that aren't necessarily true. Know how economists would study this debate, however, right? They could be concerned with how much of the climate change is caused by human activity, right? So how much of that 1.4 degree increase is the result of human beings versus the Earth's natural cycles? What is the cost of reducing this human activity in an effort to slow down climate change? So in other words, what might be the cost of reducing that temperature increase from 1.4 degrees to something lower? And then what is the benefit of reducing that temperature increase? Right? If we could get it from 1.4 degrees increase down to maybe a half a degree increase, what might be the benefits of doing so? Right? So again, those are the three questions that economists care about. Make sure you know those for the exam. And finally, be familiar with the main idea of the Green New Deal, which says that they want to get to 100% of our energy sources coming from clean and renewable energy. But again, they want to try to do that by 2030, which is pretty unrealistic. Someone said maybe by 2050, or again, given how much our energy is coming from clean and renewable energy sources right now, again, that might still be pretty unrealistic. And then know the major criticisms of the Green New Deal, right? One of which being that it has a lot of stuff on the bill that has nothing to do with the environment. So it's pushing a very strong political agenda in the name of helping the environment. Two is that the language in the bill is pretty vague. It's kind of hard to determine how these objectives are going to be achieved. And then three is that the bill is incredibly expensive. Even at the estimated minimum cost, you're looking at $51 trillion at a time when our government's already $24 trillion in debt. Oh, didn't mean to move over it just yet. So with that in mind, are there any questions at all about this slide? Does anybody have any questions here moving forward? should be noted that I have not written your exam yet. So I'll probably do that tonight. So if your question is what's on the test, just know that your guess is as good as mine. I kind of have an idea of what might be on there, but has not been written. All right, no questions on this much, so let's go ahead and move forward. So that was chapter 1. Make sure you know the terms and definitions that we talked about in chapter 2. Make sure you know the difference between each of these sets of definitions and be able to give an example of each. So we talked about renewable resources. These are resources that can replenish within the human time frame. Examples of that might be like timber stands or fisheries. We also talked about non-renewable resources, and those are ones that once you use, they're not going to renew or not going to replenish, at least not within a time frame that human beings would consider usable. So example of that might be like a natural gas deposit or a petroleum reservoir. Make sure you know the difference between a non-cumulative pollutant and a cumulative pollutant. A non-cumulative pollutant is noise pollution, right? Remember, that is a pollutant that will exist as long as the cause of the pollution is still in effect. But as soon as you shut the cause off, then that pollution goes away. It doesn't accumulate in the environment or stick around after you turn off its source. Right? A cumulative pollutant like radioactive waste is a pollutant that will exist even after you turn off the source, and it will accumulate into the environment. Right? So for example, if something produces radioactive waste, that waste is still there even after that factory or source is turned off. And the more the radioactive waste that source produces, then the more it will sit and accumulate into our current environment. When we talked about human waste as an example of something that, as long as it's below the Earth's assimilative capacity, it is non-cumulative. If it is above the Earth's assimilative capacity, then it would be considered cumulative. So there are some pollutants out there that could be one or the other, depending on how much is in existence. Then we talk about the difference between point source pollutants, right? That's where you know exactly where that pollution is coming from. So if you're driving down the road and you see a bunch of pollution being emitted from smokestacks on a factory, then again, you know exactly where that source of pollution is. Non-point source pollutants are pollutants that you don't exactly know where the exact source is, right? So for example, with agricultural chemical runoff, right? Again, you just know that this chemical runoff is ending up in the water supply. You might not know exactly where it's coming from, right? When it comes to regulating these, non-point source pollutants are much more difficult to regulate because you're not going to know who to find or by how much because you don't know where the source of the pollution is. And then know the difference between continuous versus episodic emissions. Continuous emissions are those emissions that are kind of constant as part of our production process. So for example, the emissions that come out when you drive a car or when you operate a factory, right? Or again, a waste treatment plant. But when it comes to episodic emissions, those are usually the result of freak accidents like an oil or chemical spill. Remember, when it comes to the government's job, they need to figure out how much of the continuous emissions should we allow, given that they are a part of what we produce every day to have the kind of living standards that we have. When it comes to episodic emissions, their role might be what regulations should be in place to limit the chances of these occurring, and then what regulations should be in place to ensure that they get cleaned up most effectively. All right, so again, how to deal with that accident once it happens. Are there any questions about this slide here in chapter 2 before we move on? No questions here? All right, well, let's keep it rolling. So also in chapter 2, make sure you understand the idea of sustainability and how that's demonstrated on the production possibilities curve. Remember, sustainability is when our current actions do not reduce our future opportunities. In terms of how it looks on the production possibilities curve, remember that's the curve that measures how much we can produce as a society. If our production possibilities curve shifts outward, indicating that we can produce more in the future, or stays where it is, indicating that we can produce the same amount in the future, then those actions are sustainable. But if we're operating in such a way that our production possibilities curve shifts inward in the future, meaning that we cannot produce as much, then we say that those actions are not sustainable. Right? So again, anything that reduces our future ability to produce what we could produce before, that's what we call something that is not sustainable. And no definition for assimilative capacity and why it's important for determining environmental policy. Remember, assimilative capacity is the idea that the Earth can handle a certain amount of pollutants without suffering any negative effects. And as a result of that, it might not be important that we have 100% clean and renewable energy sources, right? Given the fact that the Earth might be able to handle a little bit of pollution without necessarily being negatively affected. right? So again, perfection is not usually worth achieving in economics because the costs of achieving perfection usually outweigh the benefits of achieving that perfection, especially if there's a certain amount of imperfection that the earth can handle without suffering any negative effects. Any final questions on this or anything else in chapter 2 before we move on to chapter 3? We're going to get into more of the math and graphs and stuff. Nope, so everybody's good to go for chapter 2. Then let's go ahead and keep it rolling here. And chapter 3, make sure you understand how to derive a demand curve from people's marginal willingness to pay, and then how to derive a supply curve from this concept of marginal cost, right? Again, we have a downward sloping demand curve because when it comes to people's private marginal willingness to pay, right, the more they have of something, the less they're going to be willing to pay for it. The less they have of something, then the more they're going to be willing to pay for it, right? That law of diminishing marginal utility. And then we have that upward sloping supply curve because marginal costs tend to increase over time, right? Because as you add more and more variable resources to a fixed amount of inputs, right, you're going to see your output increase by smaller and smaller amounts. And that's what's called the law of diminishing marginal returns, right? So again, make sure you kind of understand what those rules are and how they relate to the demand and supply curve. And then understand how to use the equal marginal principle. Right, so with that in mind, I do have an example set up for you on the equal marginal principle, right? Again, this is similar to the examples that you've done already, but let's make sure that we know how to do this. So example 1, it says, assume that you want to produce 6 kilowatts of energy. How much do you save in cost using the equal marginal principle compared to splitting production equally between coal and nuclear energy? So when you're using the equal marginal principle, right, remember that you always want to take it from the cheapest source first. So if we're looking for the first source of energy, it would cost us $100 if we used it from coal and $150 if we used it from nuclear power. So we're going to go to coal first. So again, our first source comes from coal. As far as our second source, right, we could either get it from our second unit of coal, which costs $150, or our first unit of nuclear power, which also costs $150. Right there, you could say either one comes next, but we'll go ahead and say that we're going to use coal again. Right, now when it comes to the third source of power, again, you could use either your third source of coal, which costs $200, or your first source of nuclear energy, which is $150, right? So you're definitely going to go nuclear for that third source, because it's cheaper than if you use that next unit of coal. Right, now for your fourth source of energy, you could either go with your third unit of coal, costs $200, or your second unit of nuclear power, which costs $300, right? You're probably going to go coal on that. Right. When it comes to your fifth source, again, you can use coal, which costs $250, or your second source of nuclear, which costs $300. Once again, you'll probably go coal. This is cheaper. And then for your sixth source, you can go in either direction here. You can use nuclear or coal. Your fifth unit of coal or your second unit of nuclear power are going to cost the same amount. Just for the sake of variety, let's say we're going to go nuclear. So if you said that you're going to use 4 units of coal and 2 units of nuclear power, then you would get this right. If you said that you're going to use 5 units of coal or 1 unit of nuclear power, then you'd also get this right when I ask you how much of these sources you'd use. But the question asks you, how much do you save in cost using the equal marginal principle compared to splitting production equally, right? So let's go ahead and go through that particular problem here, right? So the way to do this is that if you're going to use the equal marginal principle, let's abbreviate EMP here. It's not electromagnetic pulse. That's equal marginal principle, right? Then you're just going to add up these sources that you did use. So that's 100 plus 150 plus 200 plus 250. That's the units from coal. And you can add in your units from nuclear power. That's 150 plus 300. Right. You add all those up, you should get 1,150. Right. Now, compare that to splitting evenly. Well, if you're going to split them evenly, that means that of your 6 sources, you're going to use 3 from each. So 3 from coal and 3 from nuclear power. Right. So again, if you want to split evenly here, then you just have to add those up. So that's 100 plus 150 plus 200, and then you add to that 150 plus 300 plus 450 using your 3 units of nuclear, and that should give you 1,350. So how much do you save using the equal marginal principle here? Right, well, it looks like you're going to save about $200. Right, again, just looking at the differences between them. Are there any questions about how to do a problem like this on the exam should you see it? Because hopefully everybody feels like they can do that one on the test. All right. So if there's no questions on this one, then let's go ahead and continue on. There's no questions in the chat, is there? Nope, we're good. All right. Then another thing in chapter 3 that you need to understand is the characteristics of a market equilibrium. So first of all, know how a market reaches an equilibrium, right? In that in market equilibrium, all trades generating more benefits than costs are undertaken. No trades generating more costs than benefits are undertaken, right? So remember that when we're in equilibrium, we're operating in a way that is economically efficient, assuming that there are no externalities in this market. Also, the combined area of producer and consumer surplus, which is known as total welfare, is maximized or as big as it can possibly be when we're in market equilibrium. And again, there's no excess supply or excess demand. Be able to solve for and graphically represent a market equilibrium from a set of equations, right? So for example, if I give you this set of equations here, right, with a demand curve and a supply curve, be able to figure out what the equilibrium quantity is, right? You can set those two equations equal to each other to find it, and then you can plug that quantity into your either equation or both to check and make sure you did it right, and that should give you the same number for the equilibrium price. Right, make sure you know where the demand and supply intercepts are, right, so that you can calculate consumer and producer surplus. Remember, consumer surplus is the area under the demand curve but above price, and producer surplus is the area above the supply curve but below price, and those are calculated as the area of the triangles, or 1/2 base times height. Be able to calculate total welfare by adding consumer surplus and producer surplus together. So maybe we'll do all that on the test. Right. So I'm about to go through an example of how to do that using this slide here. Is there anybody who has any questions though before I do? Nope. All right. If there are no questions, let's go ahead and do it. I'm going to exit the full screen mode here. All right, so I can start using different colors. So let's go ahead and draw ourselves a graph that we know we're going to need here in the future. So we got price and we got quantity. Right, now again, we can figure out where this demand curve is going to start. In order to do that, you just got to set Q equal to 0. If this Q is equal to 0, then our price is equal to 110. So that's where our demand curve is going to start, right here at 110. Right. And then we draw that demand curve, and it's going to hit that x-axis also right here at 110. Again, if you want to figure out where that happens, just set P equal to 0 and solve for Q. And that's where you get that 110 from. All right, and then we can figure out where the supply curve is going to start by, again, setting that Q equal to 0. Price is equal to 10. So again, if we're starting right here at maybe $10, that's going to be where our supply curve originates. So again, we got a supply curve that looks like that. It's going to intersect with our demand curve right here. And that's going to give us our equilibrium quantity. I'm going to call this the market quantity and the equilibrium price, the market price. Now, this is the socially efficient quantity and price if there is no externality present. But we might throw in an externality later and refer back to this graph. So let's just call it QM and PM for now, right? All right. So before we move on and solve for this equilibrium, are there any questions about how I found these numbers so far, or how I set up this graph? All right, on the exam, you will be allowed to have a piece of scratch paper and something to write with. So it may help you or be in your best interest to draw these graphs on your own. And then again, to help you get those right numbers that you'll be submitting through iLearn. All right, so let's go ahead and get that equilibrium. All right, so again, we're gonna solve for QM. And the way that we're gonna do that is by setting these equations equal to each other. So we're gonna set supply and demand equal. So we got 10 plus Q is equal to 110 minus Q. Right, we're gonna bring that Q over to the other side. So we got 2Q is equal to 100. And again, we got a QM that is gonna be equal to 50, solving for Q. Right, so we know that our market equilibrium quantity here is 50. And again, we can plug that back into either or both of these equations to get our equilibrium price. So PM is going to be equal to 110 minus 50, or you can plug it back into that other equation, 10 plus Q, the supply equation, which is 10 plus 50. Either way you do it, you should get it right, which is 60. Right, so that should be your equilibrium price. All right, any questions about how we figured that out before we move on here? Does anybody have any questions on that one? All right, if you've done the last two thought-provoking questions or thought-provoking assignments, then you should be fairly familiar with how to do this. All right, now let's go ahead and figure out what our consumer and producer surplus is in case I ask you to do that on the test. Right, so with that in mind, let's go ahead and figure out consumer surplus first. So our consumer surplus is the area below the demand curve, but above price. So it's going to be this area here, right? So our consumer surplus is equal to 1/2 base times height. That's how you find out the area of a triangle. And we know the dimensions of this triangle, right? The base of this triangle is this distance here of 50. And then the height of the triangle is this distance here, which is also 50, right? So it's going to be 1/2 of 50 times 50, or 1/2 of 2,500, which we know is 1,250. Any questions on that consumer surplus? Nope. All right, then we also might need to figure out producer surplus. Let's go ahead and do that with this color here. So we got producer surplus is equal to, again, 1/2 base times height. That color's kind of cosmic. All right, so that's going to be equal to, again, we have the base of 50. So we have 1/2 of 50 times the height, which is also 50. Again, just looking at this distance here. That's equal to 1,250, right, if you add the two together. Now, with that in mind, we can also get a different color out here. You just use purple. Add these two together in order to get total welfare. Total welfare is equal to that 1,250 for consumer surplus plus the 1,250 for producer surplus. It's just consumer surplus plus producer surplus. And in this case, that's going to be equal to 2,500. Right. So are there any questions about how to do any of that before we move forward here? Everybody can do that much? All right, good. So be able to do that on the exam in case I ask you a question like that. All right. Another thing that you have to know is the characteristics of a perfectly competitive market. Remember, those perfectly competitive or price taker markets occur where marginal revenue is equal to price for the firm. So whatever the price is that we just calculated in that last problem, that market price, that is going to be the marginal revenue for each item that a firm sells if they are a perfectly competitive firm. Right. Now, remember, there are a large number of firms and consumers in this market, so no one producer or consumer can change the price or has any market power. All the products are identical. Remember that one farmer's wheat is the same as another farmer's wheat, or one farmer's oranges are the same as another farmer's oranges. That's why they can't choose the price. They got to take whatever the market price for wheat or oranges is. There are no barriers to entry or exit in this particular market. Remember that there are low costs to obtaining information and engaging in transactions in this particular market. And please remember that firms can sell all they want at the market price, right? So they're not going to lower the price because they can sell everything they want at whatever the market price is. They're not going to raise it either, because if they raise the price, then nobody would buy their products because other people are selling the exact same product for cheaper. And that's why they have to charge whatever the market price is. And that's why price is equal to marginal revenue for that price taker firm. So understand how firms maximize profits by producing where marginal revenue is equal to marginal cost and be able to calculate the profits that a firm is making. So with that in mind, right, here's a potential question that you might get. So we're staying in the plastics market here. It says that the total cost is Q squared plus 50Q plus 25. Marginal cost is just the derivative of total cost with respect to Q, so 2Q plus 50. And average total cost is just total cost divided by Q. So that's Q plus 50 plus 25 divided by Q. Assume that these plastics in this the plastics is a perfectly competitive market. What is the optimal amount of production for each plastic firm? How much profit are the firms making? And is this plastic market in a long-run equilibrium? Explain why or why not. Remember that long-run equilibrium occurs when a firm is making zero economic profit. If a firm is making positive economic profits, then firms are going to jump in and try to compete away those profits. So firms are going to enter into the industry. If a firm is making negative economic profits, or what we call losses, then those firms are going to leave. And so the remaining firms will have less competition for their products. And again, they'll start making that zero economic profit. So again, know what happens in the long run if a firm is not making those zero economic profits or not in that long run equilibrium. Right. Are there any questions about that before we move through and get ready to do this example? All right, doesn't appear to be any questions so far. So let's go ahead and exit the full screen here so that we can use our different colors. All right, so again, we're staying in this plastics market where we calculated the price to be equal to 60. So that hasn't changed. And remember that for a price taker firm, right, price and marginal revenue is the same. So price is equal to marginal revenue, which is going to be equal to that 60, right? So now you got to figure out the profit maximizing rule. Which is, again, our marginal cost is equal to our marginal revenue. If marginal revenue is greater than marginal cost, well, then you start making more of this thing. If marginal cost is less than marginal revenue, then you start making less of it. Right, so we know our marginal cost equation is given to us right here, 2Q plus 50. And again, we know what marginal revenue is. It's the same as the price that we just calculated in the last problem. So that's 60. This is equal to 2Q. Subtract that 50 over to the other side. It's equal to 10. So we know that our equilibrium quantity or profit maximizing quantity that this firm should produce is going to be equal to 5 units. Right. Are there any questions about that before we move on how to calculate profit? Does anybody didn't understand how that worked? Nope. All right. So remember the formula for profit is equal to total revenue minus total cost. And so you're going to calculate both of those at that Q star that you just calculated, right? So again, our total revenue is just going to be our price times quantity, Q star. And then our total cost is just that total cost equation. That's Q squared plus 50Q plus 25, again, at whatever our Q star is. So we're just plugging these in. So our total revenue is 60 is the price times Q star of 5 minus 5 squared plus 50 times 5 plus 25. So this is going to be equal to 300 minus 5 squared is 25 plus 50 times 5 is 250 plus another 25 is 300. As it turns out, our economic profits are 0, and that means that this firm is in long-run equilibrium, so firms won't enter or leave this market, right? So with that in mind, right, again, if this number was positive, you'd have firms entering the market. If this firm was negative, or sorry, if this number was negative, you'd have firms leaving the market. If it's 0, then that means we are in long-run equilibrium. All right, so with that in mind, are there any questions about how to calculate this profit?
Sorry, I just have a quick question. So when it's 0, firms are not leaving or entering the market?
Yep.
Is that what you said? Okay, I'm sorry.
Yep. So
Thank
if
you.
the economic profit is 0, we're in long-run equilibrium. That means there's no incentive for firms to enter the market or no incentive for firms to leave. Any other questions? All right. Looking back at the last graph, do we have a question?
What was the 60 given the marginal revenue?
So 60 is what we calculated over here in this last graph when we calculated
so that was
the
part
price.
of that was sort of part of that. Okay, that makes sense.
Yeah, so again, we're staying in the plastic market here for example 3.
Okay.
Yep. Any other questions? All right. Now, what was the market equilibrium quantity here? You notice was 50. That means that there's 50 total of these items being produced by all the firms in the market. And if this is a representative firm that's producing 5 units as their profit maximizing quantity, and all firms are identical, because again, we're in a perfectly competitive market, how many firms are in this market? Who wants to throw out a guess there? Anybody?
10?
10, you got it. Right, 50 items being produced. We know that from our from our equilibrium quantity, right? Each firm is producing 5 units as their profit maximizing quantity. So there's going to be 10 firms in the market. Any questions on that before we move forward? All right, so that's it for chapter 3. So we're through the first 3 of 4 chapters here. Let's go ahead and continue on and get into chapter 4 on externalities, public goods, and how to solve for these things. Right, so chapter 4, first of all, understand what an externality is and know the difference between negative and positive externalities, what problem they pose for the market, and be able to give an example of each. So a negative externality is when external costs are created, and as a result of those external costs being created, the market tends to produce too much. So example, that might be pollution as a byproduct of your production, right? That pollution is going to negatively affect people whether or not they consented to that production happening. So again, it's going to negatively affect these third-party members who weren't part of the transaction or the decision to produce in such a way that makes them worse off. Now, positive externality is when external benefits are created, and as a result of this, the market will produce less than we'd hope for from a socially efficient or socially optimal standpoint. So for example, when it comes to flu vaccinations, right, they create an external benefit in that you can't catch the flu from the person who just got vaccinated. So you benefit from their decision to get vaccinated from the flu, even though you had no part in their decision to choose to do that, right? And again, there's going to be fewer people out there getting those flu vaccinations than we'd like there to be. So you can be able to draw a graph of a market both before and after the effect of external costs are taken into account and be able to calculate the dead weight loss. Right. So again, if there's a question that says something like this, imagine that there is a negative externality that comes from the plastic market, specifically the marginal external cost of $20 for each unit produced You need to be able to calculate the marginal social cost as our marginal private cost plus our marginal external cost. The marginal private cost is the same thing as the supply curve. So we talk about the marginal private cost, or MPC. That's just whatever your supply equation is. So you're going to add to that your marginal external cost to get your marginal social cost. And then you set the marginal social cost equal to your original demand curve to solve for the socially efficient equilibrium. And again, you're going to be able to use that to find the dimensions of the dead weight loss triangle by plugging your QM into the MSE and calculate dead weight loss that way. Are there any questions about any of these concepts before we go through this example? All right, well, let's go through how to do it, and we'll see if there's any questions then. So in order to do this, we're going to go back to our old graph here. We're just going to piggyback after the same graph because we're staying in this plastics market. And it says here that assume that the I'm trying to get a different color. Oh, there we go. I'll go with green on this one. So again, it says assume that the marginal external cost is equal to 20. Go a little bit thinner on that. Right, so how's that going to affect our market here? Well, the first thing that you're going to do is you're going to add that 20 to your original supply curve in order to figure out the marginal social cost curve. So marginal social cost is equal to that supply. What was your marginal private cost plus that marginal external cost? So in this case, that's going to be equal to 10 plus Q plus 20, which is your marginal external cost. So that's going to be 30 plus Q. So now we need to draw in our new marginal social cost curve, which is going to look something like this. So this is our MSE curve that's going to originate right here at 30. Again, we can solve that by setting that Q equal to 0, right? And solve for P. All right, and that's going to give us a new equilibrium. This is going to be our E star. And that's going to give us our socially efficient or socially optimal quantity. This is our Q star and our socially optimal price, P star. Now, in order to solve for Q star, then we need to set that marginal social cost equal to demand. So now it's the 30 plus Q equal to 110 minus Q. Again, get all your Q's together to one side. So it's going to be 2Q over here equal to 80 over here. We know that our Q star is equal to 40. Right? And then you plug that 40 into either of the two equations that you use to get that Q star. So a lot of people asked me this question and made the mistake of plugging that 40 back into their original supply curve, and then they got a different price, right? But you don't plug it back into the original supply curve. You plug it back into that MSC equation up here, the 30 plus Q, right? So again, price is equal to 30 plus the Q star we just calculated, which was 40, or you can plug it back into your original demand curve, 110 minus that 40. Either way you do it, you should get the same number, which is 70. All right. Are there any questions about that before we start talking about how to get that dead weight loss? Everybody's good with that? All right. So in order to get dead weight loss, I think the easiest way to see where it comes from is to draw out this graph. And remember that the idea here is that we are producing 50 units. But as a society, given that this production has this pollution that's producing $20 worth of marginal external cost here, we wish that we are producing less. We wish that we were producing 40 units. So we're producing 10 more units than we'd otherwise want to from society's standpoint. And that's what creates this dead weight loss given by this triangle here. right? So again, when we're calculating dead weight loss, it's that same formula, 1/2 base times height, because we're still calculating the area of a triangle. And we know the base of this triangle is that number of extra transactions that we have as a result of the fact that we are producing too much. Now, in order to figure out the height of the triangle, you need to figure out exactly where that price is. And you get that by plugging QM, or our 50 units here, into our MSC curve, right? So MSC, or marginal social cost, at QM equals 50 is just 30 plus 50. That gives us 80. 80 is what we got there, right? So again, that's going to give us the dimensions of the height of that triangle, which is now 20, right? So again, our formula for dead weight loss here is now 1/2 10 times 20, or 1/2 of 200 is $100, and that's how you calculate dead weight loss. A lot of people are only going as far as half this triangle here, where you gotta go all the way up to the MSC curve to get this distance that represents the height of that triangle. Are there any questions about how to do that? Does everybody think they can do that on the exam? Because you will have to at some point or another, either for a negative or a positive externality, or potentially both. Again, I haven't necessarily created the exam yet, but it could be one or the other.
A negative MEC, would it just shift forward on the supply curve?
So there is no such thing as a negative MEC. Marginal external cost is either positive or zero. Now there's what we call a marginal external benefit, and that would be represented by a shift to the right of the demand curve, and we're actually going to talk about that next. Remember what MEC is? That's the extra damage being caused by the production process, right? So it's the extra bad stuff that happens whenever we produce something. So it can't be negative, right? Now you can have some extra good stuff happen when you produce something, but that's what we call positive externality, and we call that marginal external benefit. Does that answer your question?
Yes, thank you.
Cool. Any other questions? We're good on this? All right. Then let's go ahead and keep on rocking here. This is where we left off. All right. So now that you know how to do all those calculations, make sure you know the potential solutions for solving for negative externalities. One of those is a Pigouvian tax, or a tax in the exact amount equal to the marginal external cost being created. So in the last problem, you'd want a tax that's equal to the $20, or the amount of that marginal external cost. Remember, the problem with that potential solution is that it's hard to know exactly how much that marginal external cost is in the real world, right? Even if politicians weren't corruptible and were in favor of actually doing things that would reach the socially efficient or socially optimal amount, it's still hard for them to know exactly what that is, right? So the second potential solution would be the Coase theorem, right? Remember, the Coase theorem says that as long as transaction costs are low and people can get together and bargain, that we're going to reach the efficient solution, right? Regardless of what that solution is, right? And so somebody's going to pay somebody else in order to make sure that the efficient solution gets reached. Who pays who depends on who has the property rights or what the law says, but somebody's definitely going to pay somebody to get to the same solution either way. Right now, the problem with the Coase theorem is that, again, transaction costs have to be low, and we have to know exactly who's causing all these externalities, and that can be a difficult thing to do in a lot of different circumstances. And then finally, you can do what's called internalizing the costs through private property rights. If you give somebody private property rights over the lake they're polluting, they're now not only causing damage to other people, but they're causing damage to themselves as well, and they might be less likely to cause that particular pollution. We talked about how the killing of endangered species might be an example of a negative externality, and that you're removing the presence of that species for everybody who has no say in whether or not you chose to kill them. And we talked about how private property rights might keep those endangered species around. We talked about a couple of solutions when it comes to elephants. We talked about how in Zimbabwe and Botswana, you gave villagers private property rights over the elephants. and you legalize the ivory trade and you allow them to sell hunting licenses to those elephants and actually cause the elephant population to drastically increase because now they're working harder to protect the elephants to make sure that there's more in the future because they'd suffer the loss of the future revenue stream if they didn't, right? As opposed to those countries that just outlawed the killing of elephants and made the ivory trade illegal, you essentially put it on the black market, which raised the price and increased poachers' desire to kill elephants. Now, you don't have to sell hunting licenses to elephants to have private property rights over them in such a way that protects them. We talked about how in Thailand you allowed those elephants to roam free on a natural preserve, and then you sold rights to tourists to go hike for those elephants and sold them the rights to feed them, bathe them, take care of them, and gave that money to the surrounding farmers who owned those elephants, right, as a way to protect them without necessarily killing them. Either way, you made sure that the elephant population either stayed where it was or increased in the future. Are there any questions about these potential solutions before we move on to the idea of positive externalities? Nope, not yet. All right. So again, be able to graph a positive externality and know the potential solutions for helping the market reach a socially optimal equilibrium. So again, if we're talking about a different market now, let's talk about the market demand for electric cars, right? So we know that we have a demand curve because we have a negative or inverse relationship between quantity and price, right? So 1800 minus 3Q is the market demand, and market supply is 300 plus 2Q. And I go and tell you that the marginal external benefit is $500 for each electric car that is purchased. Again, be able to calculate the market equilibrium, the socially efficient equilibrium, and the dead weight loss as a result of the fact that there is a marginal external benefit in this particular market. All right, so let's go ahead and get into how to do this problem. All right, so again, I always like to start by drawing a graph. I recommend that you do that as well on the test, just because it definitely helps in terms of kind of seeing where everything is. So we got price, quantity. Right now, again, we need to figure out where this demand curve is going to start. First of all, you need to know that this is the demand curve because of this inverse relationship between price and quantity. Anytime you see a negative Q, right, that's going to be demand. Anytime you see a positive Q, that's going to be supply, right? So looking at this, if we set, let me do that. So if we set Q equal to 0, then our price is equal to 1800. So we'll do 1,800 here. This is where our demand curve is going to start. So you might have a demand curve look like something like that. Now, where does it hit that x-axis? Well, in order to figure that out, then you've got to set price equal to 0 and solve for Q. Right, so if you set price equal to 0, then that's going to be 3Q equal to 1800, or Q is equal to 600. You put that 600 in here. Right. Now we need to figure out where our supply curve starts. So in order to do that, again, we set that Q equal to 0, and we know that price is equal to 300. So we have a supply curve that looks something like this. We know it's going to be a little bit flatter than demand because that magnitude is a little bit lower. So you have supply and demand here. And where the two intersect, again, this is our market equilibrium. This is how much we're actually producing. So this gives us our actual quantity, or QM, and our actual price here, PM. All right, are there any questions about how we got those numbers once again before we go through and calculate out this equilibrium? Everybody's good on that much? Cool. All right. There are no questions on that. Then let's go ahead and solve by setting our supply equal to demand. So for EM, just supply equal to demand here, or 300 plus 2Q is going to be equal to 1800 minus 3Q, Again, we got to get all our Q's together. So you add 3Q from the right side to the left side. So it's going to be 5Q. Subtract 300 from the left side to the right side. So it's going to be equal to 1,500. And we know that our QM here is going to be equal to 300. So that's how much we are producing in this particular market. Now, again, we can solve for that equilibrium price by setting or by plugging that 300 into either of those equations. So 1,800 minus 3 times 300 is equal to 900. Oh, sorry. There's a problem when you draw on these screens. It's equal to 900. Or you can plug it into the other equation, 300 plus 2 times 300 is 300 plus 600, which is also equal to 900. Oh yeah. So again, that is our market equilibrium quantity and price. But remember that our marginal, in this market, each unit produced produces a marginal external benefit of 500. So if we are drawing that out, right, this is marginal external benefit. There we go, that's what we want. All right, is equal to 500 here. So now we need to go ahead and draw out or calculate out our marginal social cost curve. Why does it look so ugly? Need a different color. We will go with purple. All right. Still ugly. There we go. All right. So this is the best we're going to get right now. So our marginal social cost is our demand curve, which is our marginal private willingness to pay, plus our marginal external benefit. Right? So our marginal external benefit is that 500. So we got 1,800 minus 3Q plus 500. That's going to be 2,300 minus 3Q. All right, so again, we need to figure out where that curve is going to originate. So this is our marginal social benefit, not marginal social cost. All right, so now we need to figure out where this curve is going to originate. Again, we can do that by setting that Q equal to 0. If you do that, price is equal to 2,300. So you want to draw a new demand curve here. Right, this is our marginal social benefit curve. And again, if you want to find out where that hits the x-axis, then you set price equal to 0. And then our Q is going to be equal to about 767 once you round it. Try to make these numbers pretty easy, but sometimes it'd be difficult to make them all work. Right, and this gives us a new socially optimal equilibrium. We'll call this E star. Now E star is going to be giving us a new socially optimal amount, Q star, and a new socially optimal price, P star. Right. All right. Are there any questions about what we've done so far before we go through and calculate out this new equilibrium? See, somebody threw something in the chat there. Oh, gotcha. Somebody knows more about this stylus than I do. So there we go. I think that might work better, right? All right. Any other questions, though, before we move on here? Jose, did you have one?
So this one we boosted up the demand curve here instead of the supply curve, and that was because this was an external benefit rather than a
Right.
cost.
Exactly. This is
So if it's a cost, it's always going to move. You're going to have like a shift in the supply curve, but if it's a benefit, you're going to have a shift in the demand curve, right?
Exactly. People
Okay.
demand external benefits. Nobody demands external costs. External costs are just supplied.
Okay.
So
Yeah, that
external
makes sense.
benefits always get added to the demand curve. External costs always get added to the supply curve.
Okay. Thank you.
Yep. Any other questions before we move on here? All right. So with that in mind, let's go ahead and calculate E star. Whatever trick we tried didn't work. So again, we're going to set our marginal social benefit curve equal to our supply curve. Right, now we have a marginal social benefit curve equal to 2,300 minus 3Q. And then we have a supply curve of 300 plus 2Q. We can add our Q's together. So we got 5Q over here equal to subtract 300 to the other side. That's equal to 2,000. So we know that our Q star is equal to 400. Right. So we got 400 here. Again, notice that we are not producing as much as the socially optimal amount dictates we should. Again, in the case of a positive externality, we always produce less than what we should produce. So there's always too little out there. Right, now again, we can plug this into our either marginal social benefit curve or into our original supply curve. Either way, you should get the same number for P star. So P star is equal to, in 2,300 minus 3 times 400. Or you can look at P star as 300 plus 2 times 400. Either way you do it, you should get the same number, which is 1,100. That is your socially efficient price, right? So again, we might have to calculate dead weight loss. Remember what dead weight loss is. It's the inefficiency that exists. In our previous graph, we were looking at marginal external costs. It's the inefficiency that exists from producing too much. In this graph, it's the inefficiency that exists because we're producing too little. In other words, it's the inefficiency that exists because we're producing 300 units instead of 400. So our dead weight loss is the area of this triangle here. Right, with that in mind, we know what the basis triangle is. It's that 100 difference in transactions. Now we just need to figure out the height of that triangle. And again, one way to do it is that we can plug our QM into our MSB equation. So marginal social benefit at QM is equal to 500, right? We can use to actually figure out what the height of this triangle would be. So again, we've got 2,300 minus 3 times, oh, sorry, that's not 500, that's 300. Again, we're just plugging this QM of 300 here into the MSB. So that's 3 minus 300. So that's 2,300 minus 900, which is 1,400. Which you should notice is exactly 500 higher than our original PM. And that makes sense because this demand curve is exactly 500 higher than that original demand curve, right? So our dead weight loss is again equal to 1/2 base times height. And in this case, that is 1/2 of 100 times that height of 500, right? or 1/2 of 50,000, which is equal to 25,000. Right, so again, that's how you calculate dead weight loss. You have to figure out the difference between your QM and your Q star. And then again, the height of that triangle is what happens when you plug your original market quantity into your new marginal social benefit curve, or it's also always equal to the amount of the marginal external benefit or the marginal external cost. That's another way that you can check to make sure you did it right. All right, are there any questions at all about these positive externalities or how to calculate these before we move on here? Oh, we're good. All right, so continuing forward. Also in chapter 4, make sure you know the definition for a public good. Remember, a public good is both non-rival in consumption, meaning that multiple people can consume it at the same time. You consuming it doesn't interfere with me consuming it. And non-excludable, right? I mean, that is impossible or at least incredibly costly to exclude non-paying customers from using the good, right? So be able to give examples of public goods versus, say, other types of goods. For example, like an outdoor fireworks show is a public good. When you look up at the fireworks, you can enjoy it. I can enjoy it at the same time. You enjoying it doesn't interfere with me enjoying it. Also, you can't exclude me from enjoying the fireworks show, right? Even if I chose not to help pay for it, unless, of course, you either kill me or stab out my eyes, which is what we mean by incredibly costly. So again, it has to have both these characteristics to be a public good. It doesn't matter whether or not the government produces it. If it doesn't have these characteristics, it is not a public good. So it's got to be both non-rival in consumption and non-excludable. So know the problem the characteristics of a public good poses for the market is that these goods tend to be undersupplied due to the presence of free riders. Remember, free riders are people who try to enjoy the benefit of the good without paying for it. Because people always try to free ride off of other people trying to provide that good, then there's always going to be fewer of these goods out there than we'd like there to be. Now, we did talk about some potential solutions, one of which is a private agreement like a homeowners association. That might be a way to make sure that we provide the optimal amount of the public good. If you have too many people or if it's too hard to get them to organize, then the government can also provide the public good and just tax you for it, right? So how do we know that there's the right amount of national defense out there? Well, the government decides what amount is best and then forces you to pay through taxes. And then also private markets can provide a public good by tying it to a private good whenever possible, right? So radio broadcast is an example of a public good. It is non-excludable and non-rival in consumption. So how do we make sure there's enough radio broadcasts out there? Well, we tie it to limited amount of advertising space that is both excludable and rival in consumption, right? How do we make sure that there's enough lighthouses out there, right? Again, lighthouses being a public good, being both non-rival in consumption and non-excludable. Well, if you use that light to guide yourself into the dock, then you have to pay a docking fee, and that fee goes to help pay for that lighthouse. Because the space at the dock is excludable, and it is rival in consumption. All right, are there any questions about what a public good is or the potential solutions for them? Yep, everybody's good on that one? All right, then let's go ahead and keep it rolling here. All right, so there's one of the very last examples that we did in class, similar to this one here. It says, which of the following portions of the demand curves of these three individuals for the water quality in a small pond are given here below, right? These are people A, B, and C. The water quality is expressed in terms of parts per million of dissolved oxygen. Water quality improves with these higher dissolved oxygen levels. The demand curve shows the marginal willingness to pay for each individual. Calculate the marginal willingness to pay if for all three together, or what we call the aggregate marginal willingness to pay, right? If the actual marginal cost of increasing dissolved oxygen is $10, what is the socially efficient level of DO in the lake, assuming these three people are the only ones involved? What is the market level of DO in the lake? So the first thing you need to do is you need to add together everybody's individual marginal willingness to pay to get the aggregate marginal willingness to pay, right? So when it comes down to it, right, if we add together all these individual marginal willingness to pays, then we've got 10 plus 10 is 20, plus 12 is 32, right, for 0. right? In order to have 1 unit of dissolved oxygen in the lake, that's 6 plus 8 is 14, plus 10 is 24. If you want 2 units, that's 4 plus 6 plus 8, which is 18, right? 3 units is 10, 4 units is 6, 5 units is 2, 6 units is 0, right? So that is the aggregate marginal willingness to pay. Now, the socially efficient level of DO is where your aggregate marginal willingness to pay is equal to your marginal cost. So wherever aggregate willingness to pay, the marginal aggregate willingness to pay is equal to marginal cost, that is your socially efficient level. With that in mind, right, the socially efficient level in this particular example is where that aggregate marginal willingness to pay is equal to 10. And that's happening right here at 3 units, right? So this is our socially efficient level. This is where society, if we could add up everybody's preferences, wants us to be. However, that's not necessarily where we're going to be, right? Where the private level of DO in the lake is, or what we call the market level, that depends on where everybody is willing to pay for it. So all 3 individuals are willing to pay for 0 units of DO, and at least 1 individual, person C here, is willing to pay for that first unit of DO. But notice that nobody is willing to pay for that second unit of dissolved oxygen in the lake. So we're going to stop there at that first unit. This is what's going to be the market level or the private level of dissolved oxygen. Notice that it's going to be less, right? Once again, because person A and B are going to try to free ride off of person C, you're not going to get that second or third unit of DO into the water there, right? So are there any questions about how to figure out the market level or the socially efficient level in a problem like this on the exam? Let me go back real quick. Let me do that. All right, any questions about how to solve this one? Nope. All right, if not, then that is all that I have prepared for you for today. Feel free to stick around if you have any questions that you'd like me to answer. I'll be happy to answer them. Right. Other than that, if you know how to do all these types of problems, then you should be good to go for the exam. I hope this review session was helpful for you. If so, just let me know, and I'll be sure to keep doing them. Right. But if not, then we can figure out a different way to do them that might work better for everybody. So it's like, let me know again if you think this was good or if you would prefer to be done a different way. If you want to look at the review session video, again, I've got a pre-recorded one posted up there. It's probably actually a little bit neater. And then I'll also make sure to post this one up there as well. All right. Any questions at all from anybody before we depart?
I had a question about the format of the exam.
Yeah, go for it.
Will the questions be like fill in the blank or like free response, or is it going to be like a free response and multiple choice?
Essentially, it's going to be like your homework. So your homework was like a practice for the test, right? So it's going to be calculated numbers that you're going to have to enter in, as well as some maybe free response, short answer, essay type questions. Right, so similar to your homework and your thought-provoking assignments, that's what the exam is going to look like. Any other questions about the format or anything else on the exam?
Are we able to see what we put for the old thought-provoking assignments to like review those and our answers?
Yeah, the way that you do that is if you go under assignments on iLearn. Can everybody still see my screen?
Yeah.
Yeah, all right. If you go under assignments on iLearn.
It's still the PowerPoint.
What's that?
Still the PowerPoint though.
Is everybody still looking at the PowerPoint?
Yeah, okay, I didn't know if it was something else.
All right. And let me get you all real quick to our iLearn course site. All right, so I'm going to start sharing my screen again and show you what the course site looks like. All right, so when you log into our course site, this is what you're gonna see. Can everybody see that okay?
Yeah.
Cool. All right. If you go under assignments, if you look at the folder that says homework assignments, follow these breadcrumbs to take a look at what your homework assignment looks like. Same thing for the weekly thought-provoking assignments. If you follow those directions, you'll be able to pull up your assignment. You'll be able to see what you put. You'll be able to see what the correct answers are and any feedback I gave you on your answers.
Okay, thank you.
Yep, no problem. Any other questions about the exam or anything else?
Professor, you said we can take it whenever we want, right?
Not necessarily. So the exam will be open for you to start anytime between 12:20 and 12:40 on Wednesday. So you have to start in that 20-minute window, and then you will have 80 minutes to complete it once you start it.
Oh, okay. Thank you.
Yeah, but you do have to take it during our regular class time on Wednesday.
And do we gotta have our cameras on?
What's that?
Do we gotta have the cameras on?
No, I'm not going to make everybody put their cameras on because there's no way I can watch 90 people at once anyway. But what me and the TA will be doing is we'll be monitoring where you go on iLearn so we can keep track of that. So if you go anywhere that's not the exam or your email, then we're going to kind of bust you for cheating, right? So in other words, don't look at the weekly modules or don't look at any of the assignments or answer keys or anything like that, right? If we see you doing that during the actual test itself, right, then we'll assume that you're cheating there. So just stay in the exam and take it just using your calculator. Again, you're allowed to scratch a piece of paper and something to write with so you can graph all this stuff out, but don't have any notes or anything like that in front of you. And we're just going to trust that you're not going to cheat there. All right. Any other questions or comments about the test? All right. If not, then good luck on the test. I'll have office hours on Wednesday from 8:30 to 10:30 so that you can drop by then and ask any maybe final questions that you might have, and I'll be happy to answer.
Thanks, Professor.
Hey, thank you. Appreciate your attention. Hopefully it was helpful.
Thank you.
Cheers, thanks.
Yep. Thank you again for attending. Yeah, I'll stick around in case anybody does have any questions. All right. Any final questions from anybody? If not, I'm going to go ahead and end the recording.
Thank you.
Yeah, thank you. Hopefully it was helpful.
Yeah, it was. Going through the examples helped.
Oh, good. I'm glad.